Module 12.2, Vocal Tract Resonances and Formants. In the last module, we spoke about the vocal tract being a variable filter. Since the various parts of the vocal tract can change shape, the resonant frequencies of the filter will change. This is what allows us to produce the different sounds of speech. We have a sound source that can change frequency. Changing the tension of the vocal folds changes pitch. As tension decreases, the vocal folds get shorter and the vibrating frequency of the vocal folds decreases. This is similar to a brass instrument player who can change pitch by changing the tension of the lips. When we are talking about the vibrating frequency of the vocal folds, we use the term fundamental frequency. This corresponds to the pitch of the voice. This is different from the fundamental frequency of a resonating system, which is its lowest resonant frequency. We indicate the voice's fundamental frequency with the symbol F0 using a capital F to differentiate it from F0 with a lowercase f, which is the lowest resonant frequency of a system. Average F0 frequencies are men 110 Hz, women 220 Hz, and children 300 Hz. There are ways that the voice is very different from most musical instruments. When you speak or sing, you are constantly changing the shape of your vocal tract, and therefore changing the resonant frequencies. A flutist cannot change the filter of the instrument. The resonant peaks of the instrument remain relatively fixed, determined mostly by the shape and size of the tube. The effective length of the tube will change, but the timbre of a flute remains relatively constant. Brass players can make some changes to the timbre of their instrument by using a mute, but otherwise, they are also dealing with a non-changing filter. As mentioned in the last module, the resonant frequencies of the vocal tract are called formants. We indicate these with the symbols F1, F2, F3, etc. These are capital letters, which differentiates them from harmonics, lowercase f1, f2, f3, and so on. A quick review. Capital F0 is the fundamental frequency, which is the vibrating frequency of the vocal folds. Capital F1, F2, F3, etc. are formant frequencies, the resonant frequencies of the vocal tract. Please note that F0 is not a formant. On average, the vocal tract air column from larynx to lips is about 17 centimeters. Using the formula F equals V over 4L, there can be a vocal tract resonance at 504 Hz. There may also be harmonics of this frequency. Here is a computer simulation showing the effects of changing vocal tract size along with changing pitch.
Abracadabra, 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 abracadabra.
We also spoke about the oral cavity being a Helmholtz resonator. The formula for a Helmholtz resonator is F equals V over 2 pi times the square root of A over V times L. The area A is affected by the opening of the lips. Say oo and then ah. Your lips are closed for oo, a small area, and open for ah, a large area. As you open your lips, the area increases and the resonant frequency increases. Volume is mostly affected by the position of the tongue in the mouth. Say ah and then ee. Your tongue is low for ah, a large volume, and high for E, a small volume. As you raise your tongue toward the roof of your mouth, the volume of air decreases, which raises the resonant frequency. The forward and back position of the tongue also affects the resonant frequency. Saying leap would be forward, low would be back. A front position tends to reduce the volume of the oral cavity. Back positions tend to increase the volume. Since frequency is inversely proportional to volume, changes in the volume of air in the oral cavity create an opposite change in resonant frequency. Length is affected by the pursing of the lips. When you say ooh, your lips are in a protruded position, a large length. Saying E, the lips are close to the teeth for a small L, which raises the resonant frequency. The opening of the lips and the height of the tongue have a great effect on F1, the first formant frequency. F1 generally ranges from 250 to 800 Hz. The rounding of the lips, as well as the front and back position of the tongue, have a great effect on F2, the second formant frequency. F2 generally ranges from 800 to 2400 Hz. This graph is called the vowel quadrilateral. The graph shows the F1 and F2 frequencies for various American English vowel sounds. The graph is upside down and backwards from a typical graph in order to show how the position of the tongue for different vowels corresponds to F1 and F2 frequencies. The vocal tract generally creates 5 to 8 formant frequencies in the audible range. But, as it turns out, only F1 and F2 are needed for us to accurately identify a vowel sound. As we speak about these formant changes, remember that these resonances are the filter that acts upon the harmonics generated by the vocal fold vibration. F0 and its harmonics are the source, and the formants are the filter frequencies. F0, the pitch of the voice, is independent of changes in formant frequencies, and vice versa. For example, I can say hoot with different F0s or fundamental frequencies. Hoot, 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 hoot. F0 is changing, but the formants stay the same. Also, I can change the shape of my vocal tract while speaking in a monotone. Hoot, heat, het, hot, hot. I'm changing the formants, but keeping the fundamental frequency constant. These graphs show the difference between a male voice with an F0 of 100 Hz and a female voice with an F0 of 200 Hz. The spectrum of the source of the male has a lower fundamental frequency, and so the harmonics are closer together in frequency than the female. In the graph, both filters are the same. The filters are applied to the source and give us the output, which is what we hear. They have amplitude peaks at the same resonant frequencies, but different amplitudes of different harmonics. In San Francisco, the Exploratorium has an exhibit which demonstrates how the change in vocal tract shape affects the sound. They have a modified duck hole that you connect to different plexiglass cylinders, which have been carved out to resemble the shape of the vocal tract for different vowels. Here's the source sound. And here are the 5 vowels.
A, I, E, O, U.
Vowel sounds are continuous sounds, and as such, are good source material for researching formant frequencies. We will look more closely at analyzing speech sounds in the next module. To review, F0 is the fundamental frequency of the vocal tract, which is the vibrating frequency of the vocal folds. F1, F2, F3, etc. are formant frequencies. They are the resonant frequencies of the vocal tract. F0 is the source, and the formants are the filter frequencies. F0 is not a formant. F0 is independent of changes in formant frequencies, and vice versa. F1 is affected by the opening of the lips and the height of the tongue. F1 generally ranges from 500 to 800 Hz. F2 is affected by rounding of the lips as well as the front and back position of the tongue. F2 generally ranges from 800 to 2400 Hz. Vowels can generally be identified with just the first two formants.